This is lesson 4.1b. We are going to graph simple, that's the topics, graphing simple functions, and our objective. I will be able to evaluate functions, finishing up our functions, our equations, find domain and range of a graph from a picture, use the vertical line test, and graph basic functions. So here we go. So we're going to start with the vocabulary term here, function notation. Okay? Function notation, put that over there on the left-hand side of your notes where we put our vocabulary because I didn't put it up at the top. Function notation is, looks like this, f of x. This is function notation. It means the same thing as y. And it reads, if you were to read this out loud, it says y is a function of x. Okay, it's a function of x. If I were to put it in more general terms, not mathy terms, but just regular people terms, our body has all kinds of functions. I won't talk about gross ones. Okay? Our lungs have a function, right? We breathe things into our lungs, and our lungs perform the function that they're built to perform, and then when we breathe things out, that was the function of our lungs. It produces something. So we breathe in air, right? Which is a combination of oxygen, nitrogen, etc. And our lungs perform some chemical function that separates the oxygen from everything else. And so it separates, we keep the oxygen and it goes to our blood and all of the good stuff. And we breathe out carbon dioxide. Yes? And then the trees breathe in the carbon dioxide, do their function, separate the carbon whatever out, and release oxygen back into the air. Okay, so the function is we breathe in. This is the X. It comes in. Oxygen, air. The lung performs its function that it's specifically set to do. And then we breathe out its function, which is the carbon dioxide. Okay, so that's a function. So y is what we get out of a function. We put x in, we get out y, and y is interchangeable with f of x. I can change them back and forth all I want. So if I want to solve an equation for x, and it's an f of x, I have to change the f of x to a y so I can solve it. So they're interchangeable. I can rearrange them however I want. Okay? All right. So let's drop some numbers into a function and see what we get out. So let's start here with a. We have been given this function. So this function is supposed to multiply by 3, square, add the number again, and then subtract 4. That's what the function is. So we're going to take the g of -3. So we're going to replace the x with a -3. So everywhere we see an x, we're going to replace with a -3. Notice I'm using parentheses. Don't forget to do that, or you might get it wrong. Replacing all of the x's with -3s. Then, of course, your calculator will perfectly do the math, but let's do it by hand. Order of operations states that I have to do this in a certain way because 4 things are happening here. There's multiplication, there's raising a number to a power, there's addition, and there's subtraction. I can't just solve this left to right and get the right answer. I have to do it in the right order. So what do I do first? The power. You bet. The power. So we're going to do 3 times -3 squared, which is 9. Positive times negative, that's -3 minus 4. And then after we do our power, what's the next operation that we're allowed to do? Multiply. So we're going to do 27 minus 3 minus 4. And now we can finish it out left to right because it's all subtraction. So we dropped in a -3, performed the function, and the function of a -3 is 20. That is the function of a -3. I could go on a graph now. I could go -3 on my x, go up to 20, plot a point, and move on. Okay, so there we have that. Let's do another one. So now we're going to plug in a k. So for b, we're going to drop in a k instead of an x. This one will probably go really fast. So 3 times, notice I'm using a parentheses, k squared plus k minus 4. Those aren't x's, by the way, they're k's. So we simplify that. So square the k, and that just k squared. Yeah. And positive times positive is positive k minus 4. Can I simplify that anymore? Can I add anything? Oh, thank you. So glad you know that. They're not like terms. So it's done. Replacing the x's with k's, that's the function of a k. All right, I'm going to do c. C is probably the one that if you're going to get it wrong, it's going to be this one. So be on guard. We're going to drop in a -t cubed for x. So here we go. 3 times -t cubed squared plus a -t cubed minus 4. Okay, so order of operations states that we have multiplication, powers, addition, subtraction. We have to do the power first. So you know what that means? That means -t cubed times -t cubed. That's what that means. So what's -t times -t? You better tell me that's positive t. And what's t cubed times t cubed? Be careful. If you are unsure, you can just take a -t cubed like so and multiply it by a -t cubed like so and expand it out if you're unsure. Negative times negative is positive. How many t's? You got it. T to the 6th power. Remember, you're distributing power to power, so you multiply. Just don't forget to give that power to that -1. All right. Plus, oh, that should probably be a minus, yes? Positive times negative is -t cubed minus 4. So let's finish it out. So we have the g of -t cubed is equal to 3. Now we're going to multiply. So 3 times t to the 6th minus t cubed minus 4. And since none of them are like terms, we're done. So just be really careful. Okay, last one. I always do this and end up with not enough room. Don't worry, we are going to finish. I know you don't believe me, but we are. Here's the last one, D. So D, we're going to drop in a k plus 1 equal to 3 times the quantity of k plus 1 squared plus k plus 1 minus 4. Okay? All right. So, what do we do first? Because look what we have. We have multiplication, powers, addition, and subtraction. Power first, yes? And when you multiply a binomial times a binomial, you're either going to have to expand it out or you know the answer. So if you can't remember what k plus 1 times k plus 1 is, I need you to learn to do this in your head. K times k is k squared. 1 times k is 1 times k is 1k, and 1 times 1 is 1. I need you to see this as 3 times k squared plus 2k's plus 1. I need you to be able to do that in your head as soon as possible. Now we're going to distribute this 1, so plus k plus 1 minus 4. Now we'll distribute. So that's 3k squared plus 6k plus 3 plus k plus 1 minus 4. And we'll quickly finish it out. by combining everything that we can and simplifying this problem. So 3k squared, and we have a 6k plus a k, so I think that's 7k, right? And then 3 plus 1 is 4, minus 4 is 0. Done. So, of all the things you're going to do for homework tonight, these are going to be the things where you can't rush through it. You have to be careful. That's the difference between a person who gets an A and an F is a person who's careful and takes their time. You guys understand? Yes? Okay. So there we have the last of the equation-y stuff that we're doing. Now we're going to move on to finding the domain and range of some random graph. So here I have the graph of an oval, and then I have the graph of this step, whatever that ends up being a graph. It's probably a piecewise function because it's just got certain pieces. It's got a diagonal line and another line. I'll teach you to graph those this year. Okay, so to identify how to find the domain and range, I'm going to do everything in my domain in red and blue, and I'll do all of my range in red. So let me just talk to you about this. My x-axis is my domain ruler. It's my domain measuring stick. It tells me a lot of information. So when I am measuring the excuse me, the domain of this oval, I'm trying to find out where is its very left point and its very right point. Would you say that this point right here would be the most left? The furthest left, yes? So what I'm going to do is I'm just going to connect it down here with a little dotted line to my measuring stick for my domain. I'm going to do the same thing with this side. So this oval stretches on my domain measuring stick right there. So that's my domain. If you want to, label it D, you can. Then my y-axis is my range measuring stick. How far does it stretch bottom to top? So you look at your very lowest point, yes, right here. Make a mark on your measuring stick. And the top point here, make a mark on your measuring stick. And then fill it in. This is the range of this graph. And that's how you're going to do that. Anytime you're finding domain and range from a graph, use your measuring sticks. Let's do the other one quickly. So if I'm going domain on this one, the point that's the very furthest left is right here. And the point that's the furthest right is right here. So from here to here, this graph stretches left to right. Then we switch bottom to top, right? This is the lowest point on the graph. This is the highest point on the graph, and it's there for a long time. So this is my stretch on my range. Okay? That's it. Okay. Questions? Hopefully that's really straightforward information. The last thing we're going to talk about today is using the vertical line test to determine pretty much immediately if one of these graphs is a function or not. Do you guys already know the vertical line test? Yeah, that's what I thought. So I'm just going to remind you really quick. And what I'm going to do is I'm just going to grab a vertical line. Remember that a function, each x can only have one y. So if I'm here on this circle at this x, how many y's does it have? It has 2. That means it's not a function, right? So in order to pass the vertical line test, when I take a vertical line, no, I want the line, and I cruise it across the graph, it better never touch it in more than one spot. And as I go across this, it's always touching it in 2 spots. So we would say, nope, not a function. So I go to this next one, which is a cubic function here. And as I cruise across, is my vertical line ever touching that curve in more than one spot? No. So guess what? It's a function. Okay? Next one. Yes or no? Yep. And last one, and we are done. I told you we could do it. Yes or no? No. Immediately. See, I'm telling you, immediately. So for homework, you're going to